Hello students, this is lecture number 8. We are studying matrices and determinant, and in this lecture we will study what means the inverse of the matrix and how to find the inverse. So in the previous lecture we saw how to find the adjoint of the matrix. So in this lecture we will study how to find the inverse of the matrix using the adjoint of the matrix. Okay, so firstly we will see the definition for the inverse of the matrix. Okay, so let A and B be any non-singular square matrices. Okay, then we say that the matrix B is inverse of matrix A if this condition is satisfying. That is, the matrix multiplication A into B is equal to I, where this I is the identity matrix. Okay, so we will say, I will repeat the definition for the inverse of the matrix. Suppose we have two matrices. This is our first matrix A and this is the second matrix B. B non-singular matrices. Non-singular matrices means what? If the determinant of both the matrices are not equal to 0, then we say that this matrix B, the second matrix B, is said to be inverse of the matrix A if the multiplication of A into B is identity matrix. Okay, and also or multiplication of B into A is the identity matrix. Okay, if this condition is satisfying, okay, if this condition is satisfying, then we say that the matrix B is the inverse of the matrix A. Okay, in general, suppose I'll take the particular example. Okay, for example, suppose I will take the matrix A is equal to, suppose, 1, 5, 1 and 6. Okay, then I want to find the suppose I have the second matrix. Suppose I have matrix B is equal to, suppose this is 6, 1 and minus 5, and this is suppose minus 1. Okay, if I will take the multiplication of A into B, then see what happens. Suppose I will consider A into B. So this is 1, 5, 1, 6 and into 6 minus 5 minus 1, 1. If you will try and find the multiplication of these matrices, we have studied how to multiply the matrices. Okay, this is a matrix. First matrix is of order 2 by 2, second matrix is of order 2 by 2. So the number of columns in the first matrix equal to number of rows in the second matrix. So the multiplication will exist. Okay, now how to multiply matrices? What we do, we take first row and first column for the first entry. Okay, and take the multiplication component wise. So this will be 6 minus 5 and this will be minus 1 plus 1, and this is 6 into 5, 30 minus 30, and this will be minus 5 plus 6, which is equal to, this will be 1, this will be 0, this will be 0, this will be 1. Okay, which is the identity matrix I2. Okay, so what we have got, we have got this multiplication A into B is equal to the identity matrix I. This means that this implies this matrix A, okay, this matrix B is said to be inverse of matrix A. Okay, so this is the definition for the inverse of the matrix, and this is how we check whether one matrix is inverse of the other matrix or not. Okay, so if suppose I have, if I will take another example. Okay, suppose I have this matrix A is equal to, suppose 2, 3, 1, 4, okay, and suppose this matrix A, matrix B, it suppose I'll take this as 7, okay. Suppose the matrix B is like 4, 2, minus 7 and minus 1. If I'll check again, this will be A into B. So put matrix A, this is 2, 7, 1, 4, and the matrix B into 4, minus 7, minus 1 and 2. Okay, if we'll take this multiplication, then see what happens. Okay, this will be 8 minus 7, this will be minus 2 plus 2, then this will be 28 minus 28, then this will be minus 7 plus 8. If you will do the calculation, this will be 1 0 0 1, which is again the identity matrix. So again this matrix B is said to be inverse of the matrix A. So this implies B is inverse of matrix A. Okay, so our questions will be to find the inverse of the matrix using adjoint method. Okay, so before that you must note one thing. Okay, if inverse of matrix A exists, okay, then the determinant of A is not equal to 0. Means what? If the inverse of the matrix is exists, then the determinant of A will not be equal to 0, and vice versa. Okay, if the determinant of the matrix is not equal to 0, it also implies that the inverse of the matrix exists. So this is the very important condition for the existence of the matrix. Okay, second one, if inverse of A exists, okay, then it is denoted by A inverse. Okay, if A has the inverse, then the inverse of the matrix will be denoted by like this, A inverse. This A inverse is called the inverse of the matrix A. Then obviously what will happen? This A into A inverse will be equal to I, or this will be A inverse into A, that is also equal to I. I is the identity matrix. Okay, now suppose we have the question to find the inverse of the matrix, okay, using the adjoint method. Okay, so firstly we will see how to find the inverse of the matrix using adjoint method. Okay, so I'll write it here, inverse of matrix using adjoint method. Okay, so to find the inverse of matrix using adjoint method, we have suppose if A be any non-singular square matrix of order n, then by adjoint method the inverse of this matrix A inverse is equal to 1 upon determinant of A into adjoint of the matrix A. Now in the previous lecture we saw how to find this thing, that is adjoint of the matrix A, and you just need to divide that adjoint matrix with the determinant of the A, then automatically you will get the A inverse. Okay, for example, suppose we have this example to find the inverse of the matrix A using adjoint method. Okay, so we need the value for A inverse, okay, such that A into A inverse will be equal to identity matrix. Okay, so we will try and find the inverse of the matrix using adjoint method. Okay, so by adjoint method, the inverse of the matrix A, that is A inverse, is equal to determinant of A into adjoint of A. Now one thing to understand here, this determinant should exist. Okay, means what? This matrix A, this should be non-singular matrix. Okay, non-singular means what? The determinant should not be equal to 0, then only the inverse of the matrix will exist, and then only we can apply this adjoint method to find the inverse of the matrix. So firstly we will check what is the inverse of the given matrix. Okay, so check what is the determinant of the given matrix. Okay, so this will be 3 into 3 minus 5 into 1, which will be 9 minus 5, which is equal to 4. So this determinant is not equal to 0. This implies the inverse A inverse exists. Okay, if this determinant is equal to 0, then the inverse of the matrix will not exist. Okay, now to use adjoint method, firstly we need to calculate this adjoint matrix A. Okay, now we know the adjoint of A is nothing but what? This is a transpose of cofactor matrix. Okay, and firstly this means what? We need to find the adjoint matrix A. To find the adjoint matrix A, we need to find the cofactor matrix first and then take its transpose. Okay, so firstly we will try and calculate what will be the cofactor matrix of A. Okay, so firstly let cofactor matrix of A be what? A11, A12, then A21, A22. Okay, then we need to find every cofactor of every element which is present in this cofactor matrix. Okay, so in the previous lecture we have seen how to find the cofactor of every element. Okay, so cofactor of every element can be found using like this formula. Okay, this is Aij is equal to minus 1 raised to I plus j into Mij. Okay, so I can find every element. Okay, firstly I will try and find the value for A11. Okay, A11 will be minus 1 raised to 1 plus 1 into M11, where M11 is the minor of the element A11. So we have this element A11 here, and its minor will be 3. Okay, so this is equal to minus 1 raised to 2 is 1 and M11 is 3. So A11 is 3. Now we can find this A12, which is minus 1 raised to 1 plus 2 into M12. Okay, so this is minus 1 raised to 1 plus 2, that is 3. This will be minus M12, and M12 is the minor of the element A12. Okay, so minor of the element A12 will be 5. So this will be value 5. Then we need to find this A21. A21 will be minus 1 raised to 2 plus 1 into M21. Okay, minus 1 raised to 2 plus 1 is nothing but minus 1. Okay, and the minor of the element A21 element is here and its minor is 1. So this value will be 1. Similarly, we can find this value A22, which will be minus 1 raised to 2 plus 2 into M22. Okay, minus 1 raised to 4 is 1, and M22 is the minor of the element A22, and which is 3. So this will be value 3. So finally we get this cofactor matrix A is equal to A11. A11 is 3, then A12 is minus 5, then A21 is minus 1, and then A22, which is 3. So this is our cofactor matrix. Okay, so we'll take this matrix to the next page. Okay, so this is our cofactor matrix. Fine. So this is nothing but this is our cofactor matrix. Okay, now what we will do, we need to find the adjoint of the matrix A, which is what? This is a transpose of the cofactor matrix of A. Okay, so take the transpose of this matrix. So convert rows to the column. This will be 3 minus 5 minus 1 and 3. So this will be the adjoint of the matrix A. Now finally we can find the inverse of the matrix, which is 1 upon determinant of A into adjoint of A. Okay, we calculated the determinant of A, which is 4, and into this adjoint of A, this is 3 minus 5 minus 1 3, and this will be our required answer for A inverse. This will be our required matrix, which is the inverse of the matrix A. Okay, next example. Suppose I want to find the inverse of the matrix using the adjoint method again. Okay, using adjoint method. Okay, now the given matrix is of order 3 by 3. Okay, so firstly we will write what means this inverse of the matrix and how we find the inverse of the matrix using the adjoint method. So if A inverse is the inverse of the matrix, so A inverse will be given by 1 upon determinant of A into adjoint of the matrix A. Okay, so our aim is to find the determinant of the matrix A and also the adjoint of the matrix A. Okay, so firstly we will try and find what is the determinant of the matrix A. So determinant of this will be 2 into 0 plus 4, then plus 1 into 1 minus 4 plus 0, which is 8, and minus 3, which is equal to 5. Okay, which is not equal to 0. This implies what? A inverse exists. Okay, now once the inverse of the matrix exists, we find the adjoint of the matrix A. Okay, and to find the adjoint of this matrix, okay, we will take this matrix to the next page. Okay, okay, so this is our matrix A, and we want to find, okay, we want to find adjoint of A, adjoint of the matrix A. Okay, and the adjoint of the matrix A is nothing but transpose of what? Cofactor matrix of A. Okay, so cofactor matrix we will consider. Okay, so let cofactor matrix of A is what? This matrix A11, A12, A13, A21, A22, A23, then this will be A31, A32, A33. Okay, now let's find out every element which is present in this matrix. Okay, so find out A11. Okay, this A11 will be minus 1 raised to 1 plus 1 into M11. M11 is the minor of the element A11. Okay, so this will be minus 1 raised to 2 into determinant of what? Determinant of this term 0, 4, minus 1 and 1. Okay, so this will be 0, 4, minus 1, 1. Okay, minus 1 square will be 1, and this will be 0 minus 4, which is equal to 4. Okay, now next element we can find, this will be A12, which is minus 1 raised to 1 plus 2 M12. Okay, minus 1 raised to 3 M12, which is a M12 is a minor of the element A12. So this is our element A12, and its minor will be, hide this row and this column, so what remains? 1, 4, 1, 1. Okay, so this will be 1, 4, 1, 1. Okay, so this is equal to minus 1 raised to 3 is minus, so this will be 1 minus 4 minus 3, so this will be plus 3. Okay, now find out the element A13, which is minus 1 raised to 1 plus 3 M13. Okay, minus 1 raised to 1 plus 3, that is minus 1 raised to 4 into M13, which is a determinant, which is the minor of the element A13. This is our element A13. So hide this row, hide this column. What remains? 1, 0, 1 minus 1. Okay, So this is 1 0 1 minus 1. Okay, minus 1 raised to 4 will be 1. So this is minus 1 minus 0, which is minus 1. Now find out what is a to 1, which will be minus 1 raised to 2 plus 1, m to 1, which is minus 1 raised to 3, and the minor of the element a to 1. This is the element a to 1. So hide this row, hide this column. So what remains? Minus 1 0, minus 1 1. Okay, so this is minus 1 0, minus 1 1, which is equal to minus 1 minus 0, which is equal to 1. Okay, so next term, that is a to 2, minus 1 raised to 2 plus 2 into m to 2. M to 2 is the minor of the element a to 2. So hide this row, hide this column. So what remains? 2 0 1 1. Okay, so this will be minus 1 raised to 4, 2 0 1 1. 2 0 1 1, which is equal to 2 minus 0, which is 2. Okay, now find out a 2 3. This will be minus 1 raised to 2 plus 3 into m 2 3, which will be minus 1 raised to 5 into the determinant of what? That will be minor of the element a 2 3. So this is our element a 2 3. So hide this row, hide this column. What remains? 2 minus 1, 1 minus 1. Okay, so this is what? 2 minus 1 and 1 minus 1. This will be 1, and this will be minus 2 plus 1, which is minus 1. Okay, now find out a 3 1, which is minus 1 raised to 3 plus 1 into m 3 1. m 3 1 is the minor of the element a 3 1. Okay, so a 3 1 is element this. So hide this column, hide this row. What remains? Minus 1 0 0 4. Okay, so this will be minus 1 0 0 4. Okay, and this will be minus 1 raised to 4. Okay, this will be 2 plus 3. This term is what? This term is 2 plus 3, which is 5. Okay, so this will be minus. Okay, so this will be plus. Okay, so this will be minus 1 raised to 4, and this will be minor of the element a 3 1. a 3 1 is what? This one. Okay, so hide this column, hide this row. So what remains? Minus 1 0 0 and 4. Okay, so let's calculate. This will be 1, and minus 4 minus 0, which is minus 4. Okay, now calculate the element a 3 2, which is minus 1 raised to 3 plus 2 into m 3 2, minus 1 raised to 3 plus 2, which is minus 1 raised to 5 into determinant, and that determinant is minor of the element a 3 2. a 3 2 element is here. So hide this row, hide this column. What remains? 2 0 1 4. Okay, so what remains here? 2 0 1 4. Okay, so to calculate this, this will be minus into 8 minus 0, which is equal to minus 8. Okay, so finally we can find this element a 3 3, which is minus 1 raised to 3 plus 3, minus 1 raised to 3 plus 3, m 3 3. This will be minus 1 raised to 6, which is 1. So minus 1 raised to 6 into determinant. Determinant is what? This determinant is what? It is a minor of the element a 3 3. Okay, so hide this row, hide this column. So what we will get? This as 2 minus 1 1 0, which is equal to minus 1 raised to 6 is 1. So this will be 0 minus minus 1, which is equal to 1. So from this we can find the cofactor matrix. Therefore cofactor matrix is equal to, cofactor matrix will be first row will contain the elements 4 3 and minus 1, 4 3 minus 1. Second row will contain the element 1 2 1. This will be 1 2 1, and the third row will contain the element minus 4 minus 8 and 1, minus 4 minus 8 and 1. So this is our cofactor matrix. So from this we can find adjoint of the matrix A, which is equal to what? The transpose of cofactor matrix. Transpose of cofactor matrix. So take its transpose. This will be 4 3 minus 1, 1 2 1, minus 4 minus 8 and 1. Okay, so this will be the adjoint of the matrix A. So finally therefore the inverse of the matrix is equal to 1 upon determinant of A into adjoint of the matrix A. Okay, now check what is the determinant of the matrix. Okay, and the determinant of the matrix is 5. Okay, so we can put the values. This will be 1 by 5, and this matrix 4 3 minus 1 1 2 1 minus 4 minus 8 and 1. So this is how we find the determinant of the square matrix. Okay, so this is how we get the matrix. Thank you.